Hi, welcome back to the channel. In this video, we are going to discuss about a new problem statement with respect to the singly linked list. Now, this is a very important question here that we are going to discuss in this with regard to singly linked list. Okay. So, in previous videos, we have discussed about the implementation of the singly linked list. Okay, and we have discussed various operations, as you can see: append, insert, delete, and print. Okay, now we are going to do another operation, and that is reversing the singly linked list. Okay, so before we proceed to write the code and the logic, let's see how the linked list can be reversed. Okay, so I have a linked list here, and I have taken this linked list, previous one. If you have followed in the previous video, the last linked list that we got was this one, 6 1 2 4. After all the operations that we performed, we appended 4 elements, then we inserted 6, then we deleted 3, then finally we get 6 1 2 4 and null. Okay, so the same linked list we have taken here. Now what will be the logic? Okay, so let's try to understand. So when you are going to reverse the linked list, what you are going to achieve? So this is the current linked list, right? After reversing the linked list, you are going to achieve 4. Okay, this points to 2, this points to 1, this points to 6, and this points, and 6 points to null. Okay, so for this result, we are going to require 3 variables. First of all, so one variable is current. I denote it by current, or let's start with head. So, and I remove this reverse linked list so not to avoid confusion. So now just consider head equal to 6. Okay, head is not a value, but it is a representation of a node. So head is 6. Current we have to take, which would be head dot next. So 6 of next is 1, so it will be this, and we have to take a previous variable which will initially be null. Right now what we have to do is very simple. We have to make head dot next as previous. Okay, we have to assign the, we have to put, or we have to orient the next of the head to point toward previous. Then we have to point previous to head. Then we will do head, we should point to current, and then current should shift to current dot next. That's the 4-step thing that we have to do, and this will be done till we don't have current as null. Okay, now let's see how this logic works. So okay, I don't expand this, I take another one. So let's consider first iteration. So in first iteration we have this condition, right? So let's consider this condition, and let's copy this condition and copy here. Now we are doing head dot next equal to p. So head dot next is p, means 6 points to, okay, 6 points to null, right? Okay, that's okay. And what is the next? P is equal to head. So P equal to head. Now the current head is 6. So P will be 6. Head equal to C. So now we have to put the reference to C as head. So head will become 1, and C will be C dot next. So C dot next is 2. So now our linked list will be null, that is pointed to 6. Reference between 6 and 1 will break, and the rest of the remaining linked list will be as it is. Okay, 4 and null. Okay, now you understand better, right? So this will be the condition after first iteration. Let's consider the second iteration. Okay, so this is our now new condition. So I copy here. Now our head is 1, our P is equal to 6, our C equal to 2. Now what we do, head dot next. Head dot next is 1 dot next. So 1 will now point to 1's next is 2. So head dot next will point head dot next will point to P, sorry, my bad. So P is 6. So it will point to 6. 1 will point to 6. P will become head. So head is 1. C is going to be, head is going to be C. So C is 2. So head is going to be this, and the C will become C dot next. So currently C is 2. 2's next is 4. So C value will become 4. So our final linked list now will become null. Null. This is pointed to 6. Now, and this is pointed, 6 is pointing to, or 1 is pointing to 6. When the reference between 1 and 2 will break, so the list will be 2, and it is pointing to 4, and 4 is pointing to null, right? So this is our next iterative, means next intermediate list. Now let's move on next here. So this is, we have got here our head equal to 2, P equal to 1, and C equal to 4, right? And C is still not null. C is current node. So our current is not equal to null yet. So this is all going in a loop, and this will continue to go till C or the current node doesn't become null. Now according to our logic, head dot next should point to P. So head dot next 2's next should point to P. P is 1. P should have contained the value of head. Head is 2. Head should contain the value of C. C is 4. And C should move to C dot next. Now 4 is pointing to null here, as you can see clearly. So it will point to null. So our list now becomes, this 6. Now this points to 1. This points to 2. Now 2 is also pointing to this. Reference between 2 and 4 breaks is no more there, and now only 4 is pointing to null, right? Now when we go to the next iteration, the C will be pointing to null. C has become null. So what will be our code then? So our code will be, or our list will be this, but since C is pointing, or current node is now pointing to null, we will come out of the loop. Now when we come out of the loop, what is that we have? So head is equal to 4, that is head will be pointing to last node. Previous will be pointing to 2. So previous is the second last node. Current is null. So now since we are out of the loop, we don't care about current. Okay. So what we have to just do is, we have to make 4 point to 2. Okay. If we make 4 point to 2, our list will be reversed. So what we have to do, head dot next. So our logic would be head dot next equal to previous, and we will make previous equal to null. Why null? Because we want to release the memory for garbage collection. Okay, so it's a good practice to do so. So according to this logic, 4 will be pointing to 2, right? So our final linked list will be null. It is pointed to by 6. Okay, and this is pointed to by 1. This is pointed by 2, and this is pointed by 4, right? So we have successfully reversed the list. Now I copy this list And if I move to the first iteration here, and if I just paste it here, as you can now see that we have successfully reversed the linked list. So this is a basic logic that we have to apply in the reversing the linked list, right? So let's do it. Okay, so we write a function public void reverse. Okay, and for head we have already taken a global variable here in the first place, so we don't need from as a parameter to pass. So we create two variables. One is current equal to head dot next. Okay, and another node is previous equal to null. It will be null initially. Okay, now we will say while current is not equal to null, as we have seen in our visual representation. What we have to do, let's see back again. We have to make head dot next as previous equal to head equal to current, and current equal to current dot next. Okay, so head dot next equal to previous. We have to then make previous equal to head, then change head to current, and then finally move the current to current dot next. Right? This is our code. Now when we break out of the loop, what we have seen? We have seen that when we break out of the loop, we get current as null. This is the condition when we are getting out of the loop. So what we do, head dot next equal to previous. So that's all we will do. So head dot next equal to previous, and let's make previous equal to null to release the memory, and that's it. Nothing else we have to do. Now let's test it out. So currently, let's again once run this code, and if we run this code, we are getting the current list as 6124 null. Okay, now let's do list dot reverse. After reversing, let's print the list, and let's see if we are getting our reverse linked list. So yeah, you can see 4216 6124, and we are successfully reversing the linked list. Okay, this is a very important interview question as well as a very important and interesting problem. You can do it recursively also. I would recommend you to try the through recursive way, and we will be discussing the recursive way in the upcoming videos. This is all for this video. Till then, bye bye.